You are asleep in a gold camp in the Rocky Mountains, and at 1 in the morning the sky turns the color of noon. Men wake up. Some of them start making breakfast because the light coming through the canvas looks exactly like sunrise. It is not sunrise. It is the sky on fire, and the sun that did it is 150 million kilometers away. On the 1st of September 1859, an English brewer's son named Richard Carrington is sketching sunspots through a telescope in his private observatory in Red Hill, south of London. He is not a professional astronomer. Astronomy is his hobby, brewing pays his bills. At 11:18 in the morning, a patch of light erupts from the sunspot group he is tracking. It flares, brightens, and vanishes in under 5 minutes. Carrington has just become the first human being to witness and record a solar flare. He has no idea what it means yet. 17 hours and 40 minutes later, the world finds out. The aurora arrives first, and arrives everywhere. Sky watchers in Colombia report the northern lights. 4 degrees from the equator, Cuba sees it, Hawaii sees it. In Queensland, Australia, people read newspapers by a red glow at midnight. The Rocky Mountain gold miners are not the only ones fooled. Across 3 continents, people wake up and reach for their pocket watches, certain that morning has come hours early. Then the wires start to burn. Telegraph operators from Boston to Washington report sparks leaping from their equipment. Paper catches fire under the telegraph keys. In Norway, an operator is knocked unconscious by a shock from his machine. And on the line between Boston and Portland, Maine, 2 operators disconnect their batteries entirely and keep sending messages. The storm itself is now powering the wires. They are for a few hours running a telegraph network on nothing but the sun. In London, the director of Kew Observatory, Balfour Stewart, has instruments built for exactly this moment. Magnetometers that trace Earth's magnetic field onto rolls of photographic paper, hour by hour. On the 1st and 2nd of September, the needles do not drift. They swing off the page. It is, Stewart will later write, the most violent disturbance his instruments have ever recorded. Across the Atlantic, a Yale mathematician named Elias Loomis spends the next 2 years doing something almost nobody else thinks to do. He writes to observatories and newspapers and ship captains around the world and collects every report of the aurora into a single global map. Loomis is not chasing a good story. He is trying to prove that this was not 4 separate strange nights in 4 separate places. It was one event, one storm, wrapped around the entire planet at once. He succeeds. The Carrington Event becomes the first geomagnetic storm ever documented as a planetary phenomenon rather than a local curiosity. Here is the part that should unsettle you. In 1859, the storm's only real target was copper wire, a few thousand kilometers of telegraph line strung across a handful of continents. The world had almost nothing else for a solar storm to break. What if the next one has everything? On the 23rd of July, 2012, the sun produced a coronal mass ejection with the same intensity as the Carrington storm. It crossed Earth's orbital path. 9 days after Earth itself had passed through that exact point in space. 9 days. Had it left the sun a week and a half earlier, it would have hit us directly at full strength in daylight. Researchers at Lloyd's of London, working with the Atmospheric and Environmental Research Group, modeled what a direct hit would actually cost a modern wired civilization. Their estimate, between $0.6 and $2.6 trillion in damage to the United States alone. Transformers burned out in power grids that take months to replace, because most of them are custom built, and there is no spare parts warehouse for a continent-sized blackout. Satellites, GPS, and the systems that quietly run air travel, banking, and food supply chains all sit exposed the same way the telegraph lines did in 1859. Except this time, almost everything we depend on runs through the same kind of vulnerable wire. Pete Riley, a physicist who models solar storm frequency for a living, ran the historical numbers and arrived at an estimate that a storm of Carrington's strength has roughly a 12% chance of hitting Earth in any given decade. Other statistical models using longer historical baselines put the odds lower, closer to 1 or 2% per decade. Even at the conservative end, this is not a once-in-a-civilization event. It is a recurring roll of the dice that we have so far mostly won. And here is what's stranger still. We would likely see it coming. A coronal mass ejection takes anywhere from 17 hours, as it did for Carrington, to 2 or 3 days to cross the distance from the Sun to Earth. The warning exists. What doesn't yet fully exist is a wired civilization built to survive the thing it's been warned about. Richard Carrington died in 1875, largely uncelebrated for what he'd seen. He never knew his name would end up attached to the benchmark every future storm gets measured against. He was, by every account, just a man who liked watching the sun closely enough to be in the right place when it did something no one had ever recorded before. That is worth sitting with. The most consequential thing a person can do is sometimes just to watch carefully and write down what actually happened. We built a civilization that assumes the sky will behave. The sun has already told us once in writing on a strip of photographic paper in a London observatory that it doesn't owe us that assumption. It has done this before. The historical record says it will eventually do it again. The only real question is whether we'll be the generation that was watching.